14.6 on the same page, 364. Also, just one sentence, okay? It says the calculated electric field produced by a long, thin wire with a uniform positive charge per unit length, lambda, along the wire. This is basically a calculus problem, but we can try to solve it without calculus. Okay, that's the situation. You have a radius r here, you have a height h here, and for this line you have a charge density lambda. Lambda is how many coulombs per meter along this line. And the lambda here is called linear density of charge. And how to calculate that? It's easy. According to definition, it's the charge divided by the length per unit length, which is meters. All right. Now just listen to me, okay? If you can understand this, it's easy. If you pick up one point on this line, you're going to have a tiny charge over here, right? What's the field on the surface here from this charge? I mean, on the same level here. What's the direction of the field right here? Suppose this is positive, the density is positive, all positive charge.
Direction is down on that point.
Therefore, this is a positive charge. You want to know the field here. You basically put down what? A positive test charge. Therefore, they will repel. Therefore, the field goes out, right?
Yes.
If you pick up this point, what's the direction of the field? Out along the radius, right? If this point go out, you see, everywhere is going out radially, right? Everywhere goes out this way. And do you have to consider the top area and the bottom area? No, all the lines just inside this horizontal plane, right? Not this way, not this way, even tilted, no, not possible. Therefore, when you consider this definition, A means the total area, but right here you have a top area. What's the direction of this area? It's this direction, right? Therefore, your field goes this way. A goes this. What's the angle? 90. The same thing happened over here. This direction goes this way. The field goes this way, you see?
Gotcha.
Therefore, the cosine 90 degree is what?
1.
This is 1.
0.
90 degree becomes 0. Therefore, 0 multiply anything is 0. Okay? Therefore, the whole surface area, only the side is effective. The top area, bottom area, due to the angle, goes to 0, right? Okay? Therefore, you have phi equals EA cosine theta, right? Then it equals equals E times A side plus A top plus A bottom, then times, I'm sorry, I just do it again. A side cosine what? Plus A top cosine what? Then plus A bottom times cosine what? You have three parts. One is the side, one is the top, one is the bottom. What's the angle here for the side? This is the surface, right?
0.
Side go out, field go out, same direction. Therefore, this is 0 degree. How about the top?
90.
Area go up, field go this way, 90 degree. Now the same thing on the bottom, 90 degree. That's the whole calculation. And this one, of course, goes to 0. This one goes to 0 because cosine 90 degree is 0. Therefore, finally, what you have is E times A, only the side, times cosine 0 is 1. You don't have to write it. Cosine 0 is 1. Therefore, you just need to calculate the side, right? So again, how to calculate the side area of a cylinder?
Is this formula for the area of the rectangle?
The circumference multiplied the height, right?
Yes, 2 pi.
Basically a rectangle.
Yes.
Therefore, here you will have E times 2 pi r times h. That's the side area. Then you have Gauss's law. The flux equals Q inside divided by epsilon 0. Therefore, here you will have E times 2 pi r h equals Q inside. Not 0, you see?
Which one?
It has a density.
Ah.
You only consider this part, right?
Yeah,
But the outside doesn't matter because Q is inside. You only calculate how much charge carried by this segment. How to calculate? How long this is?
H.